we want to take some time and develop the unit circle on video so you can go back and review it as you need to. Before we start on the circle though, we want to remind ourselves of some important things that we'll be using in the development. First of all, we want to remind ourselves why the unit circle is given the name unit circle. Remember in place value that your units position always meant the ones position, the position in a number that's immediately to the left of a decimal. Since we have associated units with 1, then it's only natural that we would think of the unit circle as being a circle with a radius equal to 1 unit. So we'll need to remember that our radius throughout the unit circle has a radius of 1. We're going to need to use that measure. We also need to remember that when we graph on a coordinate plane or the Cartesian coordinate plane, any ordered pair in our first quadrant would have a positive x and a positive y, because you have to take 2 positive motions to get a point into that first quadrant. The second quadrant, your x value will be negative and your y value will be positive because you go back from 0 and up. In the third quadrant, our ordered pairs need to be negative because you take a negative downward motion. So those are your 2 strikes to get into the third quadrant. And then getting in the fourth quadrant, we go forward again. That's a positive motion. But then we go down, so it's a negative motion. So our x coordinate or what we call the abscissa, tells us our left or right motion, whether it's a positive or negative. And then, of course, the second, the y coordinate, or the fancy name, if you will, is called the ordinate, is our up or down motion. With that in mind, we're going to see also that our x is going to be associated with the cosine function and our y with the sine function. I always have a lot of students ask, how do I keep those straight? The easiest way I know to keep them straight is just as x and y are alphabetical, cosine and sine are alphabetical. So if you can affiliate the x with the cosine and the y with the sine, I think that's the easiest way that I can think of to keep those straight. Another couple of things I want to point out to are rules that we have had so far. We have studied, if you will remember, I hope, some right triangle rules. If I have a right triangle and the acute angles of that right triangle are 30 and 60, remember that we always want to find the short leg, which is across from the 30-degree angle, if at all possible, because both the hypotenuse and the long leg are given in terms of the short leg. So we like to find the short leg if we can. If we double the short leg, we get the hypotenuse, which is always the longest side and always the side across from the right angle. If we take the short leg and multiply it by the square root of 3, that gives us the long leg, which is always across from the 60-degree angle. I want you to also remember the 45-45-90 rule. I'm going to draw it from a different perspective just so you don't get locked into seeing the right triangles a certain way all the time. Remember that a 45-45-90 triangle is an isosceles triangle. So leg 1 and leg 2 are going to be equal to each other. Isosceles triangle. So we can just refer to those as legs since they're both the same. To find the hypotenuse of a 45, 45, 90, we take one leg and multiply that by the square root of 2. Now those are all really significant, and we need to keep those in mind as we develop the unit circle. All right, we have a blank page here. I think we need to go on to, there we go. As we've talked about in class, we start counting, if you will, the degrees of the unit circle right here. And we start counting counterclockwise to make the full circle from 0 to 360. The beginning point is 0 degrees, the ending point is 360 degrees. All along the way, we have posted those degree measures that are the most important to us as we begin thinking about and studying trigonometry. We always put on the multiples of 30. So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then again back to 360. So those are important and have a nice pattern as we go around the entire circle. Now we've got to include that 45, 45, 90 triangle. And to do that, we want to number off by our 45. So starting with 0 and again going upward, 45. 2 times 45 is 90. 3 times 45. 4 times 45. 5 times 45. And our multiples of 45 continue all the way around, again, until we get to 360. So that's why we pick those degree measures. We pick those 30, 60, 90, and 45, 45, 90 multiples to go all the way around from 0 degrees to 360 degrees. Now we're also going to learn the radian measures for each of these, but I want to do that separately. I want us to go ahead and get the degree measures memorized, and I want us to get the ordered pairs affiliated with these degree measures memorized. Now let's see if I can take a little bit of this scribbling off and use okay, very good. Now, what I'm going to do is show you where the ordered pairs are coming from. Once you see where they're coming from, if you forget the memorization of these ordered pairs, you can always go back and develop this for yourself, this unit circle. So if you remember, we did this in class. I'm going to drop a perpendicular from the 30-degree point on the line straight down to the x-axis, making a right triangle. Now this 30 degrees right here means that this angle right here is 30 degrees. And I know if since I've got a 90 degree, a right angle down here, then I have to have a 60-degree angle for the other acute angle of my triangle. Now we said a while ago, in things that we need to remember, the radius of this circle is 1. So that means that this jagged green piece is 1 unit long. I didn't make that one very well. Okay, so if my hypotenuse is 1, the short leg would be half of 1, which is 1/2. And the long leg would be 1/2 times the square root of 3, or root 3 over 2. So to get my ordered pair for 30 degrees, since I go from the origin over root 3 over 2 and up 1/2 to get to the 30-degree point on the line, my ordered pair for 30 degrees is the square root of 3 over 2, 1/2. Now what is so beautiful about the unit circle, or one of the things is the symmetry of the unit circle. So your 30-degree angle, your 150-degree angle, your 210-degree angle, and your 330-degree angle are going to have ordered pairs that are very similar. Notice if I fold the circle along either the x-axis or the y-axis, those 4 angles that I have circled in green are going to match up symmetrically. So if I look at those 4, they're also the ones closest to the x-axis. They're going to have the same ordered pairs as the 30-degree angle, with one little bitty adjustment. Remember that we said anything in the second quadrant had to have a negative x and a positive y. Anything in the third quadrant had to have a negative x and a negative y. And anything in the fourth quadrant had to have a positive x and a negative y. So just by using symmetry, we can take the 30-degree information and apply it and find 3 other angles. Each of these angles, as you see, is 30 degrees from the x-axis. Or we like to say, well, I'm going to leave that at that. We'll just notice that similarity for right now. Now that we've got those in play, let's look at our 60 degree, because it's very closely related to our 30 degree. So I'm going to change my color here, and I know this is going to get marked up awfully. Let's see if I can clear it off a little bit. So that it's not so overwhelming to look at without taking off our order pairs. Okay, I think that did it. So what I want to do now is look at our 60s. And we'll put our 60s on, how about with yellow? Okay, so I'm looking at the 60-degree angle. I'm going to do the same thing. There's my point. I'm going to drop a perpendicular so that I've made a right triangle. This angle, try to overlook those 2 other rays in there. That's 60 degrees. So I have a 30 degree up here. The hypotenuse is still 1. My short leg this time is down here on the x-axis. Here's my short leg. It's 1/2 of the hypotenuse, so it's 1/2. And now my long leg is the square root of 3 times 1/2, or root 3 over 2. So you see that the 60 degree coordinate, or coordinates, are the opposite of what the 30 degree coordinates are. I come out 1/2 and then go up root 3 over 2. You're going to find, the further we get into a study of trig, that your complementary angles, like 30 and 60, your angle pairs that add up to 90, the sine of one will be the cosine of the other. See, the sine of one will be the cosine of the other if they are complementary. So that can be an easy way to help you remember. But now the 3 angles that we can derive from our 60 degrees are the 120, the 240, and the 300. Notice they are all 60 degrees from the x-axis. So they're going to all have the same angle pairs. But, again, since 120 degrees is in the second quadrant, we have to have a negative cosine and a positive sine. At 240, we're still going to have the 1/2, the root 3 over 2. But both our sine and our cosine will be negative because we're in the third quadrant. And in the fourth quadrant, we'll still have the 1/2, the root 3 over 2. But remember, in the fourth quadrant, our cosine is positive and our sine is negative. Okay? In other words, the x is positive, the y is negative. Now we're ready to take a look at the 45-degree angles. Okay? Now, as I look at the 45 degrees, I once again am going to drop perpendicular. If this angle is 45, this angle must be 45. That gives us 45, 45, 90 with a hypotenuse of 1 and 2 equal legs. So if a leg times the square root of 2 is the hypotenuse, and our hypotenuse is 1, to find a leg, we would need to divide each side by root 2. But we don't like a radical in the denominator, so we go through the process that we already know of rationalizing the denominator. That's going to give us root 2 over root 4, which is root 2 over 2. And both of my legs are the same because I've got an isosceles triangle. So both my vertical motion and my horizontal motion are going to be root 2's over 2's. So I come over root 2 over 2 and up root 2 over 2 to get to the point. So my ordered pair for 45 degrees in the first quadrant is root 2 over 2, root 2 over 2, both positive. Now I'll come over here to my 135. It's 45 degrees up from the x-axis. It's also going to have root 2 over 2, root 2 over 2. But my x has got to be negative because you have to go backward to get your x movement, to get in the second quadrant. For 225, we still have that root 2 over 2, root 2 over 2, but both motions to get into the third quadrant are negative. Then for 315, root 2 over 2, root 2 over 2, but I go in a positive direction and down to get in the third quadrant. So I've got a plus with my x here, or my cosine, and a negative for my second. So far we've talked about how to get the degree measures going around, which are multiples of 30 and multiples of 45. And we've talked about all the red angles and all the blue angles in their ordered pairs. Let's not leave out the more simple ones. The more simple ones are, of course, the purple angles. So let's get those up here. Since this is a unit circle, see if I can find another color to use here that I haven't used yet. Let's try this. Okay, I'm going to use as my ordered pair for right there. Remember, it's a unit circle. So for 0 degrees, which is the same as 360 degrees, as far as the ordered pair goes, we go out 1, but we don't go up or down. For the 90 degrees, we don't go left or right, but we go up 1 unit. For 180 degrees, we go backward 1 full unit, and we don't go up or down. Then to come down here to the point on the unit circle at 270 degrees, we don't have a left or right motion, but we do go down -1. So those are our ordered pairs for our purple points. And that should have us fixed up pretty well as why and where all of these points come from. Now let's move on to another slide. I hope you're able to fill everything in on this particular unit circle except these that are for the radians. We haven't talked about those yet. So we are not ready. Oh my goodness, I got rid of my unit circle. We're not ready to talk about those yet, but we should be able to get our see if I can get my unit circle back. We should be able to get our everything else in. There we go. Let's see. We got him back. All right, let's see what we can do with this. What we can do, we want to start again with 0, 30, 45, 60, 90. Then we're going to go 30 down from 90, so we're going to be at 120. And then we're going to go 45 down from 90. That's going to put us at 135. And then that's going to put us at 150, 180, 210, 225. These are all degrees. 240, 270, 300, 315, 330, and 360. So those are the degree measures you need to have memorized for the unit circle. Then we're going to remember 0 is at 1, 0. 90 is at 0, 1. 180 is at -1, 0. And 270 is at 0, -1. Then as we come up with our ordered pairs, we know that the 45s are all root 2 over 2s. So in the middle over here, root 2 over 2, root 2 over 2. But the x has to be negative. Then out here in the middle, root 2 over 2, root 2 over 2. Both have to be negative. Root 2 over 2, root 2 over 2. The y alone has to be negative. Then as I look at the 30, remember that I'm going to have root 3 over 2, 1/2. So over here, I'm going to have negative root 3 over 2, 1/2. And down here, I'm going to have negative root 3 over 2, -1/2. And over here, root 3 over 2, -1/2. The 60 is the inverse, or I switch over my x and my y. So I'm going to have 1/2 root 3 over 2. So for 120, I'm going to have -1/2 root 3 over 2. Down here at 240, I'm going to have -1/2 negative root 3 over 2. Then over here at 330, I'm going to have +1/2 and negative root 3 over 2. Okay, so I want you to study and see this pattern. See that if I fold along the y-axis, the different ones would match up that would touch when you fold, or if I fold along the x-axis, the same symmetry would occur. So keep that in mind. If you know the first quadrant, you should be able to tell all of the others. They follow with symmetry. But if you can't, remember the left-hand trick that we talked about and that I've attached the video for on your assignments page. We want to look at this as being the first quadrant. I should have tilted that somehow. I'm still not quite proficient in how to do that. So what we're going to do as we look at this, let me change my colors here. This would be 0 degrees, and this is my 30 degrees. 45 degrees, 60 degrees, and 90 degrees. And remember, what you're supposed to remember in the palm of the hand is the square root of blank over 2. So if I want the ordered pair for, let's say, 45 degrees, I shade in or lower down this tall man finger. See if I can find him here. He doesn't want to cooperate, so let me try just to use the red. Whoops. Let's just try to use the yellow. So if I bend him down, I have 2 fingers here, and I have 2 fingers here. So I'm going to put this number in under the radical symbol. So that would give me the square root of 2 over 2 for my x value, and then I'll put this 2 under to get my y value. Square root of 2 over 2. And that would tell me the ordered pair for 45 degrees. Then let's say I forgot the ordered pair for 60 degrees. Just remember that you lower your 60-degree finger, okay, and you're going to then have 1 finger above the 60, so your x would be the square root of 1 over 2, which is 1/2. And you have these 3 below 60, so you're going to have the square root of 3 over 2 would be your ordered pair for 60. Okay, now remember, this is a shortcut or a little trick to help you remember the first quadrant. The other quadrants you're going to have to remember the signs it takes to get into those quadrants. So don't forget that piece. It's very, very important. All right, so I want to stop on this video. It's already gotten long, and pick up on another video on the radians that we'll use to complete our unit circle.